Welcome to the Math 1 Unit 1 Study Guide Objective 2 video. Okay, we'll be looking at questions 5, 6, 7, and 8. Okay, starting with question number 5, we're talking about solving inequalities. Solving inequalities is the exact same thing as solving equations with one added step, the negative rule. Okay, the negative rule states if you multiply or divide both sides by a negative, you must flip the inequality symbol. Okay, notice how I said both sides. Okay, that'll come into play when we do question number 5 and number 6. So pay attention as we go through that for the both sides word. Okay, question number 1, I told you, number 5, we'll solve these exactly like we do for equations. So the first thing you're going to do is simplify both sides. So we're going to look at the left side first. We see we have a parentheses, and that means we need to distribute negative 2. Negative 2 times x is negative 2x, and negative 2 times positive 1 is negative 2. Pay attention to the negative times a positive giving you a negative. Okay, a lot of people want to just drop down the plus sign. We don't drop signs. We multiply our signs. Okay? And then notice how we multiplied by a negative, and this says if you multiply, you must flip the inequality. But it's to both sides. And since we only did it to the left side of our inequality, this doesn't fit our negative rule criteria. So don't worry about the sign on that particular move. Okay? So now, these are not like terms, so this side is simplified. This side is simplified because it's just a number, and then the sign will drop. Okay? So now, like just any equation, we move to step 2, move variables to one side. Well, we only have variables on one side, so check. Step 3, move constants to the other side. Okay, so if this is the variable side, the constants got to go to the other side. So we're going to add 2 to both sides. Okay, so then the negative 2 will drop. Okay, negative 2 plus 2 is 0. Okay, since we did not multiply or divide in this step, the sign will stay the same, and 12 plus 2 is 14. Okay, so now step 4 is divide by the coefficient. So we're going to divide by our coefficient. Okay, negative 2 divided by negative 2 is 1, and so that leaves us 1x. And 14 divided by negative 2 is negative 7. Okay, and so now we ask ourselves, we divided. Did we divide by a negative? And the answer is yes. This 2 and this 2, the number that we changed the question with, is negative, so we will flip the sign. Okay? And so our answer is x is less than negative 7. It's not x equals negative 7. It's x is less than negative 7. Okay? It actually can't equal it at all. But it's every number that's smaller than negative 7. For example, negative 9, negative 15, negative 383, negative 7.1, negative 7.2. It doesn't matter as long as it's less than negative 7, and those would be our answers. Okay? So, now we come back up here, and we look at question number 6. Okay? So, we separate our equation into two parts, left side, right side. On the left side, we have parentheses. On the outside of this parentheses, we have a negative 4. That means we need to distribute the negative 4 to the x. You get negative 4x. And then here's the place where people mess up. Negative 4 times a negative 1 is a positive 4. Okay? The 5x will come down. And then you'll notice that we have 3 terms, so odds are we're going to have a like term combination somewhere, and we do. We have 5x's minus 4x's, and that gives us 1x. Okay? The plus 4 will come down. Okay? Since we haven't multiplied or divided to the other side yet, the sign can just come down. We'll notice that this can't be simplified any further because they are not like terms. And so we'll just keep bringing it down. Okay? Now, step 2, move all variables to one side. It is my suggestion to always bring your variables to the left side, but you can choose whichever path you like. So I'm going to bring the negative 5x over to this side. To do that, I'm going to add 5x. X plus 5x, which is an understood 1. 1 plus 5 is 6x. The plus 4 will come down. Since we did not multiply or divide, the sign will come down, and negative 5 plus 5x is 0. And then you have the positive 40. Okay? So now we're going to move constants to the other side. So we're going to subtract 4 from both sides. And that's 0 here. And then 6x will come down. Now, that is a negative, but it's a subtraction negative, not a multiplication or division negative. So the sign will continue to be the same. And then 40 minus 4 is 36. We'll divide by 6. Divide by 6. That'll give us a 1 and an x. And then we did divide, but it was a positive, and our rule is only for the negatives. So the sign will stay the same. Okay? And 36 divided by 6 is 6. So this says x is greater than 6, which means that our answer can be anything larger than the number 6, but not equal to it, because it does not have an equals to. So then we ask ourselves the question from question number 7, would 3 be a solution to that inequality? So you say, okay, well, I'll take 3 and I'll plug it in for x. And so that would mean that you would write 3 and then greater than or equal to 6. And is that a true statement? Is 3, or I said equals to, there's no equals to there, I'm sorry. Is 3 greater than 6? Yes or no? And the answer is no. The answer, 3 is not greater than 6, so that's not a true statement, so 3 is not a solution. Question number 8. This is the tricky one. When people get one of the questions in this objective wrong, it's more than likely this one for the one mistake that they always try to make. The thing that people struggle with is this section right here. If we didn't have that, I think everybody would do great. But we've got to understand how to work this. So, when we look at this question, this is technically one term. It's one big block of stuff that's not separated. This little bar right here keeps everything together. Okay? And so you have, it's kind of like your variable term. Technically it is your variable term. And something that's not your variable term. Well, when we don't have any parentheses, okay, and we don't have variables on both sides, and technically our variable's locked up in here, the next thing to do is to move your constants to the other. So moving this positive 2 to the other side is the very, very first move that we make. Okay? So you'll subtract the 2 from both sides. Okay? It's also the furthest thing from x. That's a good rule of thumb to help you determine when you should move stuff. And if you notice, you're adding 2 to everything. Okay? The thing that you're doing something to everything with That's the first thing that's got to go, because he's messing with everybody, so he's got to get out of here. The 5 is only messing with the 3x and the negative 4. He has nothing to do with the 2, so the 2 can kind of run free and leave, if you want to think about it like that. Okay? So then you get rid of this. This whole thing will come down. 3x minus 4 over 5 is greater than, and then 6 minus 2 is 4. Now everybody should know what to do. They do the same thing. Now they can get rid of that 5 like they wanted to. 5 goes away. 3x minus 4 comes down. And we multiplied by 5 because this means divide by 5. The opposite of dividing by 5 is to multiply by 5. So they'll cancel each other out. 5 divided by 5 is 1. And that just leaves that. Okay? And then we did multiply to both sides, but you'll notice that it's a positive that we multiplied by, so the sign will stay the same. And 4 times 5 is 20. Okay? Now we have variables on one side, so we need to get constants on the other. So we're going to add 4 to both sides. Negative 4 plus 4 is 0. 3x will come down. We did not multiply or divide to both sides, so the sign will come down. 20 plus 4, 24. And then we'll divide by 3 to both sides. And that'll leave you with x is greater than 8. And that's the answer. Thank you for watching Unit 1 Study Guide Objective 2 video.